Hello and welcome to the October update from the TauNet team. And without further ado, let's get into the updates from the development team. Over to you, Karim.
Thank you, Fola, and welcome everyone to the October update for the Tau development team. Let me start with Andre. As usual, he has made significant contributions this month. He first participated with me, Ohad, and David and Fola in some deep dives into advanced concepts in the Tau language and Boolean algebra in general. He also continued his research on the use of LLMs as a bridge between natural language and the Tau language. I think there was a question about that this month. He developed a bot that generates logical tests for language models and verifies them using Z3 Solver. And to no one's surprise, basically these tests showed that current LLMs, including Anthropic's Claude and Google's Gemini's, face challenges in solving a variety of simple logical questions. He also, on the Twitter side, he substantially rewrote the Twitter bot that takes Twitter tweets and feeds them to our other social media channels. And he also upgraded the forwarding to Telegram channels based on tweet frequency and the number of likes. He also created another Telegram bot to enhance commit messages to our GitHub and utilizing LLMs with a given as input a list of changes. He finally worked on improving the reliability and consistency of our backup systems. On the development side, Tau development side, as everybody knows, we are in the final stretches of finishing up the Tau alpha release this month. And to that end, the entire team has been extremely focused on that. In particular, David, for example, has focused most of his efforts on refinements of the Tau program executions. In particular, he refactored all the previous tests and added more execution tests and debug outputs. He added a demo to show the workings of the executor in the REPL. He also added tests to the runner that should fail and to test the execution's failure modes. Removed the number of steps from the run command on request from Ohad. He added support for recursive function execution, made some minor changes in the grammar related to input and output variables, and added checks to the proper definition of input-output variables. And as a result of all the above fixes, he was able to close basically many issues that plagued the first version of the solver and the executor. On the REPL side, he fixed an issue with the keyboard stream and another issue with uninterpreted constants in the solver. He added missing assignments when calling the solver and changed the default types for the NSO factory and made them singletons. He simplified the grammars at certain points and added new operators such that not less or equal or less than or equal to the grammar. He also made several improvements in the REPL, as I said, but in the end, he worked on packaging all these artifacts in a user-friendly mode, such as deb RPM packages or macOS packages, with significant help from Tomáš. Finally, he started working on the README file as a final step of the release process. In another major development effort, Lucca as well has been focusing on satisfiability, and he's finished the implementation of the satisfiability algorithm for Tau formulas, including support for constant time positions and constants in Tau formulas. He also completed the implementation of eventual variable transformations. He optimized the quantifier elimination program and implemented an efficient simplification procedure to simplify terms across different Boolean equations. He also optimized DNF to CNF conversion and reviewed the caching during normalizations because there was a critical bug there. He made also several other bug fixes and performance improvements. And with all that, he was able to find time to assist the marketing team with some community support actions. Umar, on his side, he's been working mostly on parser debugging. He fixed a critical issue with determinism and performance. He also started working on integrating the new tree implementation into the parser, but we actually decided not to include that in the current release and leave it to a subsequent release. And last but not least, Tomáš started the month by improving the printing of tau formulas. He added syntax highlighting and formatting with lots of input from Ohad. He also fixed an ambiguity issue in grammar with Boolean function conjunction. He also added support for dynamic enabling and disabling of grammar rules, so it is possible to change the grammar midway within program parsing. He used that capability to implement two options for variable names, one short, one long option for variable names in a Tau language. We call that the charvar option. And he added that support in the REPL. So within the REPL, you can turn on and turn off parsing options. And he did some general code refactoring where he cleaned up the global namespace. But finally, and not least, he actually was able to cross-compile a Windows version of the Tau REPL so that those in the community who are using Windows can use and test Tau from their Windows machine. That's all for the month of October. Back to you, Fola.
All right, fantastic. Thank you so much, Karim. All right, I'll pass it over to David now for his update for the month.
Thank you, Fola. Hi, everyone. This month, I've been working in several tasks. Regarding testnet, as usual, I've been participating in the discussions, but one of the main focus this month has been the testing of the executor. In particular, I have refactored the previous test and add several more to check the executor and also failing conditions in it. I have added a demo to show the workings of the executor. I have removed the number of steps from the run command as proposed by Ohad. I have also allowed the use of recursive functions when we want to execute a program. It's so in the demo in particular. I have made minor changes to the grammar, and also I have add checks for the proper definition of input-output variables and report errors if missing or if we have wrong types. As a result of all the above, I have found several bugs in the solver that I have fixed. In particular, I needed to make a technical change in the solver to simplify further the intermediate results that we get using a strong normal form instead of BF reduction. I have fixed a couple of issues that I found in the when computing LGRS. Also, I have fixed the solver so that we could use uninterpreted constants, and I have added more tests to further check the solver. Apart from that, I have made several general improvements in the code. Some of them were required to fix some issues. Others were just needed to go forward. In particular, I have constrained to non-type the infer constant types because till now the user could write whatever type he wants. So we needed to restrain everything to check that the types are the ones that we are supporting in the REPL. I have added default types into the NSO factory, which is a factory that describes in general terms Boolean algebras, and we needed to have a default type. In this case, it will be tau. And I have made the factories singletons in order to reduce the amount of memory and also improve the execution to avoid, because we avoid to create factories all the time. We just need one factory for each possible Boolean algebra we are dealing with. And also I've been reviewing the README and reviewing the error, debug, and trace messages that we have in the REPL. Currently, I'm working in the addition of several operators. I have updated the grammar, and also I have added the builders, but I still need to add the definitions in the hook mechanism. And also I'm working in the packaging of all the artifacts that we have. For example, for using RPM, dev, whatever. Once I finish this, I will jump into few fixes that need to be done. And that's all for my month. Thank you.
All right, David, a brilliant month. Thank you very much. I now pass it over to Tomáš for his update this month.
Thank you, Fola. Hello, everyone. I've been doing some debugging of normalization, and to improve readability of formulas, I've added initial syntax highlighting and formatting. I've also changed printing of Boolean functions so they are more compact. Then I worked with Umar on disambiguation of Tau grammar, namely the conjunction of Boolean functions. Then I've added a charvar option, which allows to toggle between two formats of variable names. Default single character format allows to have variables in conjunction next to each other without operator or separator. And when we turn charvar off, it enables variables with longer names, but then they need a white space or operator to separate them. And this required to add a parser feature to enable or disable grammar rules without the need to reload or to have multiple parsers in memory. And in the REPL, there are commands to access options. It's a get, set, and toggle. And I've added also commands enable and disable. I've also I've cleaned the global namespace, and then I've continued on porting parser and Tau to Windows. So I've added a support for terminals on Windows, and I've been working on MinGV toolchain for creating Windows executables. That's all from me. Thank you.
Fantastic. Thank you so much, Tomáš.
Thank you, Fola. Hello, everyone. This month, I've been able to finish a lot of major tasks. The first one would be the full satisfiability algorithm for tau formulas, a subtask I started last month but finished this month with handling constant time positions during this satisfiability algorithm. And also I started last month to implement eventual variables and finished that this month. The eventual variable transformation is our way of transforming several sometimes statements into a single one so that it can efficiently and effectively be computed using our satisfiability algorithm von Taba. The next major task was an advanced simplification procedure that can simplify terms across different Boolean functions, so that things you specify about certain variables or constants in one part of the formula under a certain Boolean equation can now be taken into account at all across this single formula. Then I optimized the DNF and CNF conversions we already had in the system alongside with the quantifier elimination algorithm. I also reviewed our handling of caching during normalization so that we recompute as few calculations as necessary. And aside from this, there were also just general a lot of bug fixes and performance improvements in all parts of the normalization system. So for me, this month has been mostly about the normalizer and some community support here and there. And yeah, it's been a very productive time, and thank you very much.
All right, excellent. And last but not least, over to you, Ohad.
So I continued working with Professor Paris on the network specification language, and about the Henkin quantifiers. In the full generality, we saw at the beginning we saw a big success, and we were very optimistic that we can carry this out to the full generality. But very, very surprisingly, it turns out to be undecidable. So what we do now is consider a different kind of Henkin function, of Henkin's column functions, which are column functions for Henkin quantifiers, that are called, it doesn't matter the name, it's called split in conditional semi-simple Boolean functions. And this should be good enough. This should support a software-specific network specification such that we can extract clients of that network in the Tau language. This is for sure decidable in this setting, but to figure out how exactly to do it in a practical way, that's what we work on right now.
All right. Thank you so much for tuning in. That was a very, very exciting month, and we're very much looking forward to this month as well. And we'll see you again on our socials. That's X, that's TauLogicAI. That's Tau Chain on Telegram. And it's TauNet Agoras, Agrs on Reddit. All right, fantastic. Thanks so much for tuning in. We'll see you again next month.